Cartridge Assembly Comparison Test. This video presents a performance comparison of NEST's self-developed cartridges against 3 other products. The data show that NEST cartridges perform similarly while offering more consistent quality. 1. Appearance and dimensions. One box from each of the 4 products was examined. Inspect overall appearance, sealing surface, and aluminum cap of the cartridges. Results: overall appearance, NEST for scratches, C9, A5, B18 plus 3 silicone oil spots. Sealing surface, all 4 products showed no defects. Aluminum cap, NEST comparable to competitor A, better than C, superior to B. Key conclusion: NEST and competitor A have superior appearance compared to B and C. NEST products undergo 100% CCD inspection to ensure quality. Cartridge body and tray dimension measurement. The dimensions of cartridges and their trays were measured. Key conclusion: competitor CE's tray dimensions deviate significantly from the national standard, while NEST, competitor A, and competitor B comply with the standard and are compatible with automated production lines. Tray appearance inspection and seal strength test. Visual inspection was conducted on the inner or outer surfaces and heat-sealed edges, along with seal strength testing. Key conclusion: uneven heat sealing was observed in competitor B trays, while NEST and competitor A met appearance requirements. 2. Silicone oil content test. 32 samples from each of the 3 products were tested. Silicone oil on the inner surface was extracted using a solvent, followed by distillation and weighing of the residue. The average silicone oil content was calculated by difference. Key conclusion: all 3 products had silicone oil content below 1.0 mg or unit, meeting national standards. Among them, NEST and competitor B showed lower silicone oil levels and better siliconization performance. 3. Biological performance test. Sub-visible particle test. 10 samples from each of the 4 products were tested. The cartridges were rinsed sequentially with isopropanol and water. After degaussing, samples were gently stirred and analyzed using a particle counter to determine the number of sub-visible particles. Key conclusion: all 4 products met national standard requirements. After adding particle test water and simulating transportation by agitation, results showed that NEST and competitor C performed better than competitor A and B. Endotoxin test. 3 samples from each of the 4 products were tested. Endotoxin-free water was added, followed by mixing with Lau reagent and chromogenic substrate. Samples were incubated at 37°C and analyzed using a microplate reader. Key conclusion: endotoxin levels of all 4 products were far below 0.05 U or national standard requirement. Sterility test. 30 samples from each of the 4 products were tested. Aluminum caps were aseptically removed, and samples were placed into TZB and FTEM media. The bottle bodies were also immersed in reagent-filled tubes. Samples were incubated for 14 days to monitor microbial growth. Key conclusion: no microbial contamination was detected in any of the 4 products, all meeting national standard requirements. Microbial challenge test. NEST and competitor A used moist heat sterilization, while competitor B and C used EO sterilization. Results show that EO has limited penetration to eliminate microorganisms in the gap between the cap and bottle, whereas moist heat sterilization is more effective. Physical performance test. Internal stress test. 30 samples from each product were examined using a polarized stress tester to check for stress patterns and measure optical path difference. Key conclusion: no stress patterns were observed. All products meet national standards. Silicone oil uniformity test. 30 samples from each product were tested. After removing the aluminum caps, glass beads were added and gently shaken to contact the inner walls, observing coverage uniformity. Key conclusion: NEST showed the best uniformity and smooth plunger operation. NEST and competitor C outperformed competitor A and B. Seal integrity test. 30 samples from each product were filled with crystal violet solution, pistons assembled and marked, then placed in a vacuum chamber at -95 kPa for 30 minutes. Piston position and bottle or cap integrity were checked. Key conclusion: no leakage or piston displacement observed. All products meet national standards. Liquid leakage resistance test. 20 samples from each product were filled with crystal violet solution, pistons assembled and vented. A 60 N vertical force was applied to the piston for 1 minute using a force gauge. Key conclusion: no leakage observed. All products meet national standards. Multi-puncture debris and liquid leakage test. 20 samples from each product were filled with crystal violet solution and assembled with pen needles. Each stopper was punctured 10 times to simulate actual use. Debris was recorded. Then a 10N vertical force was applied to the piston for 1 minute to check for leakage. Key conclusion: no debris or leakage observed. All products meet national standards. Sliding performance test. 30 samples from each product were tested after removing aluminum caps and stoppers. Using an automatic force tester, conventional sliding, multi-step sliding, and sliding after accelerated aging, freezing, and shaking were evaluated. Starting and sustained forces were recorded. Key conclusion: no significant differences among products. All meet national standards. NEST showed the lowest variation in starting or sustained force CV 7.77%, indicating superior siliconization stability. 5. Pen loading performance test. Pressing force. Cartridges were loaded into pen injectors at maximum dose. An automatic force tester measured pressing force, recording starting and sustained forces. Key conclusion: starting forces of all 4 products met national standards. NEST, competitor B, and C showed no significant differences and all outperformed competitor A. Drop and leakage test. Products were subjected to drop and leakage testing. Key conclusion: breakage rates for all 4 products were well below national standards, and no droplets formed after simulated injection.